So good morning. Uh, Welcome back to our VLSI design lecture series. In this, we're going to today see about the CMOS fabrication. So what is this fabrication? CMOS is not. First of all, we see the definition for CMOS. What is a CMOS? It is a combination of NMOS and PMOS. So the N-type material and P-type material will combine and give you a logic, that is the CMOS logic. So here the CMOS logic is created or fabricated in a process that is called CMOS fabrication process. So there are three processes used, that is the N-well process, P-well process and twin-tip process. So what is the meaning of N-well, P-well and twin-tip? So the CMOS can be obtained by integrating both the NMOS and PMOS transistor over the same silicon layer. So this is one of the N-well process, and in this N-well technology, what happens is N-type well is diffused on P substrate, and in P-well technology, what happens is P-type well is diffused in the N-type substrate. So this is the vice versa will happen. So what is the twin tip? In both the N-well process and P-well process get fabricated in a single silicon vapor is our twin tip. So this is the basic step. First we are taking a P substrate, and next we giving the oxidation, and in the oxidation layer we going to give a photoresist layer in order to do the masking, that is to create a well. So in order to create a well, we have to do a masking and etching process. So in the masking we are using the photolithic process. In this step, a desired pattern of openness using this is made using a stencil. Next, the removal of hold resist layer, which is help of the etching layer, and the SiO2 layer, which are protected by the photoresist or are not affected. So next, the type of N-type well is formed in the P substrate. So this is the N-well process. The N-fill is created in the P substrate. Next, the unwanted removal of the materials are done by the photoresist, and again the etching process is created. The vapor is immersed in an etching solution, that is a hydrochloric acid, which removes the oxide from the areas from which it opens or to be diffused. So here final the SiO2 also diffused, and the N-well is completely created in the P substrate. So and finally the terminals of the transistor are get formed. The terminals of the transistor is nothing but the we know the terminals of this transistor, that is source, drain and the gate. So these are get formed in the uh, P substrate. So in order to create an NMOS, that is the N-well. So next finally, by masking and diffusion, for making regions diffusion of N-type purities, use a masking. So finally the oxide layer is stripped off. So everything is get created CMOS using N-well. So N-well is created. Next, P-type diffusion, similar to the N-type diffusion, forming the terminals of PMOSs. Terminals of PMOS, P-type diffusion are carried out. So next, the layering of thick field oxide. Before forming the metal terminals, a thick field oxide is laid out from a protective layer where the vapor and no terminals are required. So finally, the metallization and assigning the terminals names in the P substrate. Then what is the thing happening in the P-well process? So in the P-well process is similar to the N-well process. Here instead of P-type substrate we are using the N-type substrate, and instead of P-type diffusion instead of N-type diffusion we are using a P-type diffusion or carried out. So a complete P-well process is created. So next is the twin tip process. So as I told before, twin tip is the combination of both N-well and P-well. So here we can control both the p-type and n-type material with the help of the twin type process. A lightly doped material with an epitaxy layer is used in order to protect the system from some short leakages, that is the latch up problems in the chip. We are using this twin type process. High purity silicon layer are used. So here the diagram, here it shows the source and drain are formed using ion implantation methods. Cuts are formed by making portions, metal cuts, and metallization for drawing the metal contacts. So finally we have a small assessment in the topic. So what is the CMOS technology? What is this P-well? Where is P-well is created? In fabrication, in CMOS fabrication, the photoresist layer is exposed. So this is here answers. So explanation of the answer, where we'll be mainly using the CMOS technology in the highly used in microcontrollers. All our controllers and processors were used of the CMOS technology. The second assessment is P-well is created in N substrate, right? N type substrate, and N well is created in P substrate. Though so the confusion will come while drawing the diagram for this fabrication. Next, in the CMOS fabrication, photoresist layer is used to expose the UV light, right? So it is to mark the regions where the diffusion is to be takes place. So here is the assessment, short assessment in the fabrication. With this we stop the session and we continue in the next classes. Thank you.